Cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS started cloud computing in 2006, where they sold IT infrastructure services to businesses as web services. It provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform owns and maintains the network-connected hardware required for these services while you provision and use what you need. It helps to build and run applications, and it can also be used for deployment and management of applications. It's available to hundreds of thousands of customers across 190 countries. It offers powerful resources at low operational cost. The classically provisioning services that has is like Goldilocks problem, and with AWS you can elastically scale up and scale down. Cloud benefits include the ability to deliver innovative new features to the market quicker, focusing on adding differentiated value, making new ideas feasible that were once out of reach, having experimentation become fast and low risk, being able to adjust to fit any workload, helping businesses to serve their customers globally without the need for expensive time-consuming expansion, deploying web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, etc., and connecting to personal infrastructure by private dedicated connectivity. More benefits are trade capital expense for variable expense, benefiting from massive economies of scale, stop guessing about capacity, increasing speed and agility, stopping spending money running and maintaining data centers and going global in minutes. So for trading capital expense, for variable expense, you pay for what you consume and you only pay when you are consuming. When benefiting from massive economies of scale, it's lower variable costs and you can achieve higher economies of scale, and it leads to lower prices. When stopping guessing about capacity, you access as much or as little as needed, and you can scale up or down when necessary with a few minutes notice. Increasing speed and agility, so you reduce the time it takes to make resources available, and it causes a large increase in agility due to the cost and time to experiment being extraordinarily lower. Stop spending money running and maintaining data centers, so focus on your own customers, and then going global in minutes is where you deploy your application in multiple regions around the world extremely quickly in just a few simple steps. This means you can provide lower latency and a better experience of your customers at a small cost. Total cost of ownership. So total cost of ownership reduces the need to invest in large capital decisions. It provides a pay-as-you-go model that allows you to invest in the capacity you need to use. TCO calculators allows you to estimate the cost and savings. Calculators also modify assumptions that best meet your business needs. Calculator provides directional guidance on possible savings. The tool is built on an underlying calculation model. It generates a fair assessment of value that a customer may achieve. And it's important to note that the TCO calculator results should only be used as an approximation. As said before in all of the live streams, the videos can just be found in the description once the live stream is ended. Alright, now we're going to be going over types of cloud computing. So there are several different models of cloud computing, and they allow different amount of control of web services. The three main types are infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. So infrastructure as a service, which IaaS, it contains the basic building blocks for cloud IT. It typically provides access to networking features, computers, and data storage space. It provides the highest level of flexibility in management. It's most similar to existing IT resources, and it has instant computing infrastructure. Platform as a service, or PaaS, removes the need for organizations to manage the underlying infrastructure. It allows focus on the deployment and management of applications. It helps business owners be more efficient. It disregards human concern over resource procurement, capacity planning, software maintenance, patching, etc. And it combines hardware and software components. Software as a service, or SaaS, provides customers with a completed product that is run and managed by the service provider. SaaS is usually referred to as end-user applications. There is no user concern about service maintenance or how infrastructure is managed. You only need to know how you will use the software. And web-based email. An example of this is a web-based email that is used to send and receive emails without having to manage future editions. How to deploy cloud infrastructure easily. So there are 4 key areas that make this deployment easy. Highly trusted global infrastructure, providing broad compatibility with all popular workloads, fast and secure private networking, and having tools to control access to all cloud resources. So for highly trusted global infrastructure, it's designed for high security and availability needs of the large enterprises. It offers capabilities that restrict unauthorized access or usage without sacrificing flexibility, and it serves as a backup for all features. For providing broad compatibility with all popular workloads, it can spin up virtual servers, hard drives, databases, networks, and more. And it's easily set up virtual servers using Linux or Windows. For fast and secure private networking, it's where you provision a private section of the AWS cloud that you define and retain control of. It's done with simple IP networking. Cloud environment becomes an extension of your on-premises environment. It uses a standard pipe that encrypts data when it moves from your environment to the cloud. More data creates dedicated network connection from your existing data centers to AWS, and it gives you predictable network performance increase by bypassing the public internet. Alright, and then finally, tools to control access to all cloud resources. This is where you create and manage users and integrate with your existing identity systems. And it gives greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. Okay, so now for the cloud. Cloud-based applications are fully developed in the cloud, and applications in the cloud are created in the cloud. Or they are migrated from an existing infrastructure to take advantage of benefits. Cloud-based applications can be built on low-level infrastructure and can also use higher services that provide detachment from management, architecting, and scaling goals. Hybrid is a way to connect infrastructure and applications. It connects cloud-based resources and existing resources. And a common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting cloud resources to the internal system. It runs applications as both cloud and on-premise and can access AWS wherever necessary. On-premise is also referred to as the private cloud and uses virtualization and resource management tools. On-premises deployment leads to the inability to receive cloud computing benefits, and it's used to provide dedicated resources. Typically, it's the same as previous IT infrastructure, and it uses application management and virtualization technologies to attempt to increase resource usage. AWS security. So this infrastructure installs safeguards to protect privacy, and data is kept in highly secure data centers. It manages dozens of compliance programs, and segments of compliance have already been completed. It has the highest security without user managing their own facility. It saves money at the same time, and you can scale security with your AWS cloud usage, and it maintains security regardless of the cloud size. AWS Analytics Services. So this is a set of services that handle every step of the analytics process. The services are powerful, flexible, and yet simple to use, enabling organizations to put their unorganized data to work efficiently. Example services are Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. Elasticsearch is an open source search and analytics engine used to log analytics, real-time application monitoring, and user-click analytics. Amazon Kinesis enables you to absorb, buffer, and process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes of organized and disorganized data across your warehouse, operational database, and data lake using a language called Standard Query Language. Amazon Athena is an interactive question service that makes it simple to analyze data in Amazon Edge through using SQL. AWS Compute Services. So this offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. Examples of this include Amazon ECL, Lightsail, and Amazon Elastic Container Service. For EC2, it obtains service quickly and inexpensively. For Lightsail, it creates a virtual private server on AWS, and for Elastic Container Service, it runs in Docker containers. which contain software that are in standardized units known as containers. These containers package everything a software needs to run, including libraries, system tools, code, and runtime. Database services are necessary databases for applications such as managed relational, non-relational data warehouse, in-memory data store, and graph databases. Amazon DynamoDB is a fast and flexible database service for any workload. Here you only pay for what you utilize, and the key value of the database that delivers nearly instantaneous single-digit performance at any scale. It's built to handle internet applications and fully managed service, and it handles more than 1 trillion requests per day. Amazon Relational Database Service, or RDS, is a relational database service with 6 well-known database engines, and this can be set up, operate, and scaled in a few steps. And the last part of our presentation starts with AWS Developer Tools. So this contains code and automatically creates, evaluates, and deploys applications. It's a set of services that quickly and carefully deliver software, and services store and hold control of your application source code. It's used for constant integration, continuous delivery, infrastructure as a code, and monitoring. AWS Code Pipeline can create an end-to-end software release workflow using services. It's continuous delivery service that automates release of the pipelines in order to have fast and reliable application as well as infrastructure updates, and it effectively and efficiently delivers features and updates. For AWS Cloud Development Kit, it's an open software development structure to define your cloud application resources using known programming languages. It supplies cloud applications and this can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. AWS CDK utilizes familiarity and expressive power of programming languages to modeling your applications. AWS Code Deploy is a tool that installs applications and updates servers. It lowers workload on developers and quickens release of new products and features. Code Deploy makes it simple for users to rapidly release new features, helps dodge downtime during application development, and deals with the complexity of updating applications. And positives of this include automated deployments, minimized downtime, centralized control, and being easy to adopt. AWS Management Tools. These allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control without restricting your development speed. AWS CloudWatch is a service that was built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. It gathers monitoring and operational data in the form of logs, metrics, events, providing you with a linked view of AWS resources, applications, and services that run on AWS and on-premises servers. AWS CloudFormation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again, and it models infrastructure using a simple text file. AWS Systems Manager allows full control of the structure of AWS and automates the tasks needed for smooth operations. It helps guarantee security and compliance and detects a problem quickly. AWS Networking and Content Delivery Services allows you to isolate your cloud infrastructure, scale request handling capacity, and connect physical network to private or virtual network. The networking products would work together to meet requirements. Elastic Load Balancing coordinates with Amazon Virtual Private Cloud to give networking and security features. It distributes application traffic among different services. It handles traffic in one or multiple availability zones, and it improves scalability or adjustability of your applications. AWS Storage Services are a reliable, secure, and adjustable location for your data. It offers a wide variety of cloud storage services to support both application and archival compliance requirements. Archival requirements are the dates when things can be archived or stored away, and they're pretty hard to get back. One can choose from different options to build the base of your cloud storage management solution. In AWS, the different types of this include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And that's going to be it for this presentation. Thank you for watching, and we will see you in another live stream.